Hello everyone and welcome back to the Intro Algebra video lecture series. Today we are going to be starting the process of graphing linear equations, and this is going to be a very long and involved process, so this is actually going to be several videos. So first of all, we're going to always graph linear equations in what is called the rectangular coordinate system, which is also called the Cartesian plane. The Cartesian plane is named after its creator, the famous philosopher René Descartes. You might recognize him as the same man who said, "I think, therefore I am." He's the one that came up with this. Now, the legend around this is that he wanted to find a way to mathematically represent the position of a fly on a wall, and the wall represents a two-dimensional or flat plane. So the Cartesian plane is a system of coordinates based on the perpendicular intersection of what are called two axes. The horizontal axis is called the x-axis. The vertical axis is called the y-axis. The variables x and y may not always be used depending on the context, but you have a horizontal axis and a vertical axis, and these are represented as horizontal and vertical lines. Now, I have a picture over here of the intersection of the x-axis and the y-axis, and notice how each of them have arrows on the end. What that means is that both the x-axis and the y-axis continue on forever and ever in both directions. So the x-axis is going to continue forever and ever left and right, and the y-axis is going to continue forever and ever up and down. So what we have drawn here is just a piece of the Cartesian plane. Now, the point where they intersect, the point where the x and the y-axis meet, is called the origin. The origin is where we start. So the origin has an x-coordinate of 0 and a y-coordinate of 0. And it is going to be represented as what is called an ordered pair 0, 0. And this is going to be our starting point for any time that we plot any points. Every other ordered pair in the Cartesian plane is represented as what is called an ordered pair or coordinates x, y. Every point is going to have an x-coordinate, which is the first number listed, and a y-coordinate, which is the second number listed. The x-coordinate, or the first number listed, is the horizontal distance away from the origin. The y-coordinate, or the second number listed, is the vertical distance away from the origin. Now, x and y are either going to be positive numbers or negative numbers. Movements up and right are considered positive. Movements down and left are considered negative. So, for example, the position of the fly's head here on the wall, since the fly's head is 3 units to the left of the origin, it has an x-coordinate of -3. And since the y's head is 4 units above the origin, it has a y-coordinate of +4. So the fly's head can be represented as the coordinates -3, 4. -3 means 3 units to the left of the origin. +4 means 4 units above the origin. Now, when you are plotting points, you're always going to have both an x-coordinate and a y-coordinate. The x-coordinate is always the number that's listed first, and this is the horizontal distance. If the x-coordinate is positive, that means you are going to move to the right. If the x-coordinate is negative, that means you're going to move to the left. Now, the y-coordinate is the second number listed. This is going to be the vertical distance away from the origin. If the y-coordinate is positive, you move up. If the y-coordinate is negative, you move down. Now remember, if you do not draw a point until you have moved both horizontally and vertically. So make sure that you have done any horizontal and vertical movements before you draw that point. You should draw your point after the vertical movements. So we're going to take each of these points and we are going to plot them on this coordinate grid. So for the point 3, 1, the x-coordinate is +3 and the y-coordinate is +1. So since the x-coordinate is a positive 3, that means this is going to be a movement to the right 3. And since that y-coordinate is positive 1, that is going to be a movement up 1. So we're going to start at the origin. We're going to count 3 units to the right. Then we're going to count 1 unit up. Now that we have moved both right and up, we're going to draw our point. So that is the point 3, 1. So then for negative 4, 2, the x-coordinate is negative 4. That is the horizontal distance. And since it is negative, this is going to be a movement left 4. The y-coordinate is positive 2. And since it's positive, this is going to be a movement up 2. So from the origin, I'm going to count left 4 spaces. 1, 2, 3, 4. And I'm going to count up 2. 1, 2. After you have moved both left and up, then you are going to draw your point. Then for negative 1, negative 3, since the x-coordinate is negative 1, this is going to be a movement left 1. Since the y-coordinate is negative 3, this is going to be a movement down 3. So we're going to go from the origin. We're going to count to the left 1, and then we're going to count down 1, 2, 3. Then once we've moved both left and down, we're going to draw our point. These lines are just glitches. Ignore them. You're drawing points. That's it. So then for this next one, 3, negative 1, the x-coordinate is 3, so that is a movement to the right 3. The y-coordinate is negative 1, so that is a movement down 1. So we're going to go from the origin, we're going to count to the right 1, 2, 3, and we're going to count down 1. Now that we've moved both right and down, we're going to draw our point. Now, anytime one of your coordinates is 0, that means that you are not moving at all in that direction. So for the point negative 4, 0, the x-coordinate is negative 4, which means we're going to move to the left 4 units. But since the y-coordinate is 0, that means we are not going to move up or down at all. There are no movements up or down. So we're just going to count to the left 4. Not move up or down any, so that is our point right there, and it is sitting on the x-axis. So 0, 0, this is also known as the origin, so the origin is that point right there in the middle. Then for 3, 0, we're going to count to the right 3. Since the y-coordinate is 0, we're not going to move up or down at all. Now for 0, 2, the x-coordinate is 0, which means we are not moving left or right at all. The y-coordinate is 2, which means we're going to move up 2. So we're going to go from the origin, we're not going to move left or right, and then we're just going to move up 2. So 0, 2 is right there. So for 0, negative 1, we're not going to move left or right any, we're just going to move down 1. So that point right there on the y-axis is 0, negative 1. Then for 0, negative 4, we're not going to move left or right any. We're going to just move down 4. And that right there is 0, negative 4. So then we're going to plot each of these. If you would like to attempt these on your own, please just pause the video and then resume when you are finished. So then for 5, 2, the x-coordinate is 5. That is a movement to the right 5. Y-coordinate is 2, that is a movement up 2. So we're going to go from the origin, we're going to count to the right 5, and then we're going to move up 2, and that is our point. So then for 3, negative 4, we're going to move to the right 3 and down 4. So right 1, 2, 3, down 1, 2, 3, 4, and then that is our point. For negative 1, 1, we're going to move to the left 1 and up 1. For 0, 3, we're not going to move left or right. We're just going to move up 3. And then for negative 4, negative 2, we're going to move to the left 4 and down 2. What you can also do is, knowing that the x-coordinate is always the horizontal distance and the y-coordinate is the vertical distance, is you can take existing points and you can figure out what their coordinates are. So we have 4 points here, and we're going to find the coordinates of each of them. Starting with A, so remember this is the origin right there. It doesn't look like we moved left or right any, so because we did not move left or right, that means your x-coordinate is 0. This is sitting up here at 3 units above the origin, so the y-coordinate is positive 3. So then for point B, which is over here, point B looks like it is 5 units to the left of the origin, so its x-coordinate is negative 5. B is also 3 units above the origin, so its y-coordinate is 3. So then for C, for the x-coordinate, we have moved 2 units to the left of the origin, so its x-coordinate is negative 2. However, since it is sitting on the x-axis, that means we did not move up or down at all, and that means our y-coordinate is 0. So then for D, D was 1 unit to the right of the origin, so its x-coordinate is 1. It is also 3 units below the origin, so its y-coordinate is negative 3. Now, the x and the y-axis will split the 2D plane into 4 sections that are called quadrants. So these quadrants are also known as regions, and they are numbered with the Roman numerals 1 through 4 as shown here. So this quadrant here on the top right is quadrant 1. Next here on the top left is quadrant 2. Bottom left is quadrant 3. Bottom right is quadrant 4. So in each quadrant, the x and the y values are either going to be positive or negative. So in quadrant 1, both your x-coordinate and your y-coordinate are both positive. In quadrant 2, since that was a movement left and up, that means the x-coordinates are negative and the y-coordinates are positive. For quadrant 3, since these would involve movements left and down, both the x and the y coordinates are negative in quadrant 3. Then for quadrant 4, since this is right and down, the x coordinates are positive and the y coordinates are negative. So without graphing, you can graph if you want to, but without graphing, we're going to figure out which quadrant each of these points is going to be located in. So for negative 5, 5, this would involve a movement left 5 and up 5. So movements left and up would put you in quadrant 2. For 7, 20, both of these coordinates are positive. Quadrant 1 has both x coordinates and y coordinates that are both positive. Yes, you can have a coordinate that's a decimal. So for 1.3, negative 4, this would be right 1.3 units and down 4 units. Right and down would put you in quadrant 4. Then for negative 4, negative 5, the quadrant where both coordinates are negative is quadrant 3, since this is left and down. Now, we're going to be graphing what are called lines, which are, in the coordinate plane, you're going to have a line that is running through it. That line is going to cross the x-axis and the y-axis. So the x-intercept is the point where the graph either touches or crosses the x-axis. Now, any point that is sitting on the x-axis is going to have a y-coordinate of 0 because there were no movements up or down. Now, the y-intercept is the point where a graph crosses the y-axis. And any point that is sitting on the y-axis has an x-coordinate of 0 because there were no movements left or right. Now, don't depend on the variables x and y always being used, especially in a lot of application problems where the line actually stands for something real life. It might make sense to have other variables besides x and y being used. For example, t is a very common variable used to stand for time. C is a very common variable used to stand for cost. So let's say that, let's say this real life situation, the amount you get in a paycheck depends on the time worked, not the other way around. So since paycheck depends on time, we say that the paycheck is what is called the dependent variable, since paycheck is depending on something else, time. Now, time, which doesn't depend on anything, is what is called the independent variable. So each of these relations is going to have an independent variable and a dependent variable. They may not always be x and y. Generally, x is the independent variable and y is the dependent variable. However, if you have some sort of real-life context, like paycheck and time, it may not make sense to use x and y. You might want to use p for paycheck and t for time, in which case p would be the dependent variable and t would be the independent variable. So generally, we are going to assign the independent variable to the horizontal axis, and the dependent variable is going to go on the vertical axis. Now, the reason why it's important to identify independent and dependent variables is because when your graph actually stands for something realistic, you can interpret that graph by simply looking at it and observing patterns and remembering what your horizontal axis stands for and what your vertical axis stands for. So when graphs are used in a real-life context, they're going to show a relationship between two variables, such as paycheck and time. So if you connect points to form lines or curves, you can see trends and use those trends to make predictions, and it'll allow you to see patterns. So the trend among plotted points on a coordinate shows the relationship between two variables. Is this increasing? Is it decreasing? Is it constant? What is it doing? So when you read a graph, you are going to read it like the English language, from left to right. Graphs are always read from left to right, just like English. So this graph here stands for something realistic. This graph shows the cost C of parking in a lot for time t hours. Since the cost to park depends on the time parked, C is what is called the dependent variable, and t, time, which doesn't depend on anything, is called the independent variable. So what we're going to do is we're going to read this graph from left to right, and we're going to interpret it, and we're going to explain what that means about the cost to park. So as we read it from left to right, we can see that this line is clearly sloping up, and it is increasing as I trace this from left to right. So what that means is that as the time increases, the cost to park also increases. Now for this next one, this graph is going to show the cost that a shipping company charges to send a package depending on the package's weight. So the cost is going to be represented as the variable C, and the weight of the package is going to be represented as the variable W. Since cost depends on the weight, the cost to ship depends on how much the package weighs, the variable C, or cost, is the dependent variable, and the weight W is the independent variable, because cost depends on weight. So what we're going to do is we're just going to kind of trace this graph, and we're going to interpret what this graph would mean in the context of the problem. So as we move this way on the horizontal axis, the weight of the package W is going up. The independent variable W was put on the horizontal axis. The dependent variable C was put on the vertical axis. So for this first part here, for this part that is highlighted in pink, if you trace it from left to right, you can see that it is not moving up or down any. It's remaining what is called constant. So that means for these first few lower weights, the cost to ship the package remains constant until you get to a certain weight. Then, as the weight continues to increase, the cost to ship also starts to increase. And we can see that because as the weight goes up, the graph is sloping up, so that means cost is also going up. So those are what are called, those lines can be represented in what is called an equation in two variables. These graphs will show a relationship between two variables, such as package weight and cost to ship the package. You could represent that as an equation that involves both C and W. So the variables that are used in these equations are not always X and Y. The parking problem will be represented in terms of C and T. So the solution to a two-variable equation is any ordered pair whose coordinates make the equation true. So if you ever want to check to see if a point lies on a line or if a point is a solution to a two-variable equation, all you have to do is plug the x and the y coordinates into their appropriate variables, simplify, and see if a true statement results. So we're going to see if the ordered pair -3, 7 is a solution to the two-variable equation y equals -2x plus 1. So our variables here are x and y. Remember, the first number that is listed is always the x coordinate. The second variable listed is always the y coordinate. So to check to see if this is a solution, I'm going to plug -3 into where I see x with parentheses around it. And I'm going to plug 7 in for where I see y. And then I'm going to fully simplify and see what happens. Leave my equal sign parked in the middle where it is. So in for y, I'm going to plug in 7. Then on the right here, I'm going to plug -3 in for x with parentheses around it. So I'm going to follow order of operations here on the right. I'm going to multiply first. -2 times -3 is +6. Then I'm going to finish up by adding 6 plus 1, which is 7. Since 7 does equal 7, this is what is called a true statement. So is -3, 7 a solution to this equation? Yes. Because we got the same number on both sides of the equal sign, that means this ordered pair is a solution to this equation. Now, what we are also going to do with these two variable equations is we are actually going to graph them. So we are going to graph them as a series of points that are all connected with a line, and we're going to focus on lines in this class. So we've got the equation y equals 2/3 x minus 3. And there are a lot of solutions to this equation, and we're going to graph it as a line. So what we're going to be doing a lot of are plugging in x coordinates and figuring out what y coordinates go with a given x coordinate. So we're going to find the y coordinate that goes with an x coordinate of 6. So to figure that out, I'm going to go back into the two variable equation, and I'm going to plug in 6 with parentheses around it in where I see x. I'm going to fully simplify, and then I'm going to figure out what the y coordinate would be. So I'm going to take y, I'm going to leave it alone, equals 2/3. In for x, I'm going to plug in 6 with parentheses around it, minus 3. Then I'm going to simplify by following order of operations. The multiplication comes first, so 2/3 times 6 is 4. Then I'm going to subtract 4 minus 3 gives us 1. So 1 is the y-coordinate that goes with the x-coordinate of 6. So if you were to write this as an ordered pair, this would be the point 6, 1. Now, these two variable equations are also what are called relations. A relation is any set of ordered pairs. So what a line is basically going to be is it's going to be a whole bunch of ordered pairs that are all connected with a straight line, and that is what is called a relation. So relations, they are sets of ordered pairs. And relations always have what are called domain and range. So the domain of a relation is the list of all of the first coordinates or x coordinates. It is also known as the set of inputs, the first coordinates that are listed. The range of a relation is a list of all of the second coordinates or the y-coordinates of each of the ordered pairs. The range is going to be the set of outputs. So the graph of a relation is the graph of all of the ordered pairs in the relation graphed together on the same coordinate plane. Now, not all relations are created equal. There are different types of relations. A function is a very special and very important type of relation. A function is a special type of relation where no two ordered pairs have the same x-coordinate, or no two ordered pairs have the same first coordinate. It is very specific that no two ordered pairs will have the same x-coordinate. If you have no two ordered pairs having the same x-coordinate, it is a function. Now, notice it doesn't care about the y-coordinate, so if you can have repeated second coordinates and still be a function, it's the first coordinates that we're really going to be focusing on. So this is an example of a relation. This relation contains the points -2, -5, 0, -5, 1, -5, and 4, -5. So what we're going to do is we're going to find the domain and range of this relation and use that to figure out if it is a function. So the domain is going to be the list of all of the first coordinates. So the domain is going to be -2, 0, 1, and 4. The range of the relation is going to be the list of all of the second coordinates, which, since these are all the same, your range is just -5. You don't have to list this 4 times. Now, to determine if a relation is a function, you look at the first coordinates. If no two ordered pairs have the same first coordinate, it is a function. I don't care that all of these have the same y-coordinate. We're focusing on the x-coordinates. -2, 0, 1, and 4. None of those first coordinates were the same, so because no two points have the same x-coordinate, this is a function. So this next one is another example of a relation. It is the set of ordered pairs -10, 10, -1, 1, 0, 0, and -1, -1. So what we're going to do is we're going to find the domain and the range of this relation and then figure out if it is a function. So the domain is the list of all of the first coordinates. So the domain is going to be -10, -1, and 0. You do not need to list -1 twice. Now, the range of the relation is going to be the list of all of the second coordinates, which are 10, 1, 0, and -1. So then to figure out whether this relation is a function, you're going to look at the x-coordinates or the first coordinates. If there are two different ordered pairs that have the same x-coordinate, it is not a function. So if you look at this ordered pair there and this ordered pair there, notice how they have the same first coordinate. Because these 2 points have the same first coordinate, it is not a function. Functions are extremely important, and functions are what you are going to be working with for the entirety of your next math courses. So functions, because they are so special, have their own notation. So functions are usually given by, they're usually given a name that is some sort of letter, such as F, G, H, capital F, capital G, and others. This is going to be the name of the function. And the function notation looks like this. And this is read as f of x. So this is read as f of x. The f here, this letter in front, is the name of the function. So in this case, the function is named f. This variable that is inside the parentheses is your independent variable, which is also known as your input variable. So this means that the function is called f, and the independent variable is x. The input variable can also be thought of as x. So if you have a number that is plugged inside the parentheses, what that means is you are going to plug in that value for that variable. So for example, here is a function, f of x equals x squared minus 2. So this is our function. Its name is f, and the independent variable is x. So then we're going to take that function and we're going to find f of 2. So to find f of 2, since 2 is in parentheses, we're going to take 2 and we are going to plug it into our function f of x into every single spot that we see an x. So I'm going to take my function f and I'm going to plug 2 into every single spot where I see an x. Please use parentheses. So I'm going to plug a 2 with parentheses right there. Anything that is not an x needs to be left alone and left exactly where it is. So f of 2 will be 2 squared minus 2, which will be 4 minus 2. That gives us f of 2 is equal to 2. So what this means is that the function f evaluated at the point x equals 2 is equal to 2. So here are two more examples of functions. So for this first one, we're given the function f of x equals 2x plus 3. So the name of the function is f. The input variable is x. Then we're going to find f of 4. So what f of 4 means is that we're going to take the function called f, and we're going to plug a 4 into every single spot that we see a variable. So for f of 4, I'm going to take my function f here, and I'm going to plug a 4 with parentheses around it in where I see an x. Anything that is not an x needs to be left alone and left where it is. So f of 4 will be 2 times parentheses 4 plus 3. So 2 times 4 will give you 8. 8 plus 3 will be 11. So f of 4 is equal to 11. So then for this last one, we have our function q of r equals 5r squared minus r minus 4. So the function's name is q. The input variable is r. So when we are finding q of 2, we're going to take the function called q, and we're going to plug 2 into every single spot we see the variable r. So since r appears more than once, you are going to plug 2 with parentheses around it into every single spot that you see in r. So we're going to plug a 2 in right there and right there. Anything that is not in r needs to be left alone and left where it is. So that will give us 5 times parentheses 2 squared minus, in place of r, I'm going to substitute another 2, minus 4. So let's follow order of operations. 2 squared is 4. Then I'm going to do the multiplication. So 5 times 4 is 20. And then 20 minus 2 minus 4 will give you a q of 2 of 14. Alright, so this is where we are going to leave this video. In the next video, we are going to be taking those linear equations into variables, and we are going to draw their graphs. So, thank you all very much for watching, and I will see you all in the next video for graphing linear equations into variables.